Hi everyone, this question is from chapter 8.1 and this is question number 18. So it is about the sample proportions distribution. So it says, suppose you know that the distribution of sample proportion of women employees is normal with mean of 0.42 and standard deviation of 0.21. So it is, in other words, telling us that if you took thousands of samples and calculated thousands of respective sample proportions and plotted those sample proportions in a histogram, the distribution would be normal with a mean of all those sample proportions equal to 0.42, 0.42, and a standard deviation of 0.21. So this standard deviation of p hats would be 0.21. Now suppose you select a random sample of employees and find that the proportion of women in that single sample is 0.45. So out of all these thousands of samples, you picked one of these samples and calculated its proportion, which turned out to be 0.45. 0.45. I'm writing 0.45 to the right of 0.42 because it's bigger. And part A is asking us how many standard deviation is the sample proportion from the mean of the distribution of all proportions. In other words, we need to find out this distance in terms of how many standard deviation away this guy is from this 0.42. So in other words, part A is simply asking us to find the z-value of this 0.45. To do that, I can figure out how far away 0.45 is from 0.42, which is the mean, 0.42. And in terms of standard deviation, how many standard deviation away it is. So that's our simple definition of z-value. So if I use my calculator, 0.45 minus 0.42 gives me 0.03, and I divide that by 0.21 to get my z-value. So in this case, z-value is 0.03 divided by 0.21. 0.21. So it gives me z-value of 0.143 approximately. So I can just call it 0.14. 0.14. So 0.45 is 0.14 standard deviation away from the mean 0.42. In terms of z-scale, we could say that the corresponding z-value of 0.45 is 0.14. And of course, the z-value for the mean is always 0 because the mean is exactly 0 unit away from the mean. Let's see what part B is asking us. Part B, what is the probability that a second sample selected would have a proportion greater than 0.45? In other words, out of all these thousands of sample proportions, if I randomly picked one sample proportion, what are the chances that it will be bigger than 0.45, i.e., we need to figure out the area under this curve, which is to the right of this 0.45. So if I go to the Z table, I can figure out the percentile position of this 0.14, which will tell me the percentage of the area which is to the left of this 0.45. Let's figure that out first. So Z table and then 0.14. 0.1 is right here. 0.14 is the value that coordinates this 0.1 and this 0.04. So it looks like the percentile position for 0.14 is 0.5557. 0.5557. So that's the percentile position for this Z value. And if you want to express it in terms of percentage, then you multiply this value with 100%, or simpler trick, just move this decimal point to the right by 2 digits, which will give you 55.57%. So the area of this dotted region is going to be 55.57%, and therefore the area under the curve, which is this striped region, is going to be 100% minus this 55.7%. So if I do 100% minus 55.57%, let's use a calculator. I'll take 100% and then deduct 55.57. 55.57. That gives me a result of 44.43%. So the area of this dotted region is 44.43%, and that is the probability of the sample proportion being bigger than 0.45. I hope that is helpful to you, and I hope now you can handle this kind of questions in your quizzes or exams. And I'll be back with some more question solution for you. Thank you.